Hi, fourth grade families. In this video, I'm going to show you how to add fractions with denominators of 10 and 100. So I'm going to present my screen. All right, so I have some examples here when we're adding fractions with unlike denominators, because when we're adding 2/10 plus 30 100ths, we can't just add those straight across like we would normally do if they were like denominators. They're unlike denominators, they're not the same. So first, we're going to use tenths and hundreds interchangeably by using area models to show that. So if I have a fraction, such as 3/10, and that we could shade on this model because this model has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total pieces. So 3/10, I'm going to shade in 3/10. Okay, so now this area model is out of 100, and we can check because there are 10 rows and 10 columns. 10 times 10 is 100. Now we want to make an equivalent fraction, and we'll know because the area models will show the same value or the same area shaded in. So if we had 3 columns shaded in here, we can actually just shade in 3 columns on our hundreds model. And we can see very quickly that they hold the same area. And we can also check using some strategies that we've learned, such as creating an equivalent fraction. So I know that I can multiply 10 times 10 to get this denominator. So I do the same to the top. 3 times 10 would be 30. So 3/10 is equal to 30 100ths. And if you count, we have 3 columns of 10s, that's 30. So we did shade the correct amount. So if I have 5/10, I'm going to shade in 5, so I have 3 already. The equivalent fraction, we would shade in 5 columns over here. Oops, I need to shade in all of them. All right, so 10 times 10 is 100. 5 times 10 would be 50. And some of you might notice the pattern that all we're doing is adding a 0 to both of these numbers. So let's try it the other way now. We have 70 100ths. I'm going to shade in 7 of my columns. 1, 2, 3, 4, 5, 6, 7. Guess I need to shade in all of the columns though. All right, a 70 100ths. So I shaded in 7 of my columns. So I'm going to shade in 7 of my columns over here. This, if we had our question mark here, you can always work the same way. 10 times 10 is 100, so blank times 10 would get us 70. That would be 7. Or you could also divide. 100 divided by 10 is 10. 70 divided by 10 is 7. So 7/10 equals 70 100ths. And it follows the same pattern. All we do is add a 0 to both of these numbers, or we take one away. So now that we kind of have a pattern of how to use tenths and hundredths interchangeably, now we can try to add these two fractions. So 2/10 plus 30 100ths. We can't just add across. It's not, I know first instinct, we want to say 23/10 or 23 100ths, but that's not going to be the sum because we can't add across when the denominators are different. So we need to change one of these fractions so that the denominators are the same. You can either choose to keep it at tenths or 100ths. I'm going to change it to 100ths. So I'm going to take 2/10. And I want the denominator to now be 100. So I need to make an equivalent fraction that has 100 as our denominator. So 10 times 10 is 100. 2 times 10 is 20. And some of you didn't need to multiply. You might have noticed, oh, I just add zeros to both of those numbers. So now 2/10 is the same thing as 20 100ths. So if I want to just add the zeros up here, now I can add them straight across. So 20 plus 30 is 50. And our denominator stays the same. So 50 100ths. Now, We'll do the same problem, but instead of changing 2/10, we'll change 30/100ths. Put this back to 2/10. All right, so now let's say we want the denominator to be 10. So we'll put 30/100ths down here. And our goal is to get a denominator of 10. So if you like to multiply, you can always work from this side, from right to left. So 10 times 10 is 100. So what number times 10 would get us 30? Or you could divide. 100 divided by 10 would be 10. So do the same thing to the top. 30 divided by 10 would be 3. And some of you might have known, oh, I just take off the zeros when I'm changing my denominator to 10. So now 30/100, sorry, is equivalent to 3/10. They're the same value. So now I can change my fraction up here. Now that I have the same denominator, I can just add straight across. So 2 plus 3 is 5, and we keep our denominator the same. And if you notice, the last time our sum was 50/100ths, well, 50/100ths is equivalent to 5/10. So you were able to get the correct sum no matter which fraction you decided to change. Now, sometimes you won't be able to change both. For instance, let's change this to 5/10, and let's change this to 2/100ths. All right, so if I decide I want to change 2/100ths into tenths, so my goal is to get 10 as my denominator. 100 divided by 10 would be 10. But 2 divided by 10, that wouldn't really get us a whole number for the top. And we could try it the other way. Blank times 10 would get us 2. It doesn't work that way. So our only option is to change 5/10. So sometimes you have to look at the numbers and see which number you'll have to create an equivalent fraction for. So I need to change 5/10, and I need to change it into something over 100. That way we'll both have a denominator of 100. So I know that if I'm adding a 0 to both sides, this will be a 50. So now I can add the fractions because they'll have like denominators. So 50 plus 2 would be 52, and our denominator stays the same. So 52/100ths would be our sum. So when you're adding fractions with unlike denominators, you have to make the denominators the same. And when you're dealing with 10s and 100ths, you just need to choose if you want to have your denominator be a 10 or 100, and you need to create an equivalent fraction. Feel free to use area models if you would rather shade in the values, or you can always just create equivalent fractions by multiplying the numerator and the denominator by the same number.